Thank you for joining us. Another edition of our virtual SIGGRAPH sessions. As you all know, there is no conference in DC this year. It's been canceled for the reasons we all know, but we're still going to bring you some interesting conversations, guests who have interesting solutions and technologies to actually talk about. And today, we're going to focus on the integration of production with visual effects post and everything that relates to the use of game engines in producing imagery. So lens data, how do you translate that into an environment where you need to combine live action and computer graphics imagery? So that's the topic. And today with us, we have three of our good friends, Snehal Patel from Zeiss, and we also have Nic Hatch, from Ncam, and Andy Blondin from Epic Games. So jumping right in, I'm going to ask a question to Snehal first. Snehal, how did Zeiss think that the importance of extracting layers of metadata from optics? You guys are an optics company, world-renowned. How did it come about that you guys said, okay, it's really important and people are going to need that? Or was it a reflection or a response to demand that you've received from professionals in the field?
Yeah, definitely a demand that's been going on for decades upon decades. It's not something new to be able to get data from lenses, right? There's a lot of what we call smart lenses on the market. For cinematography, there's two main communication protocols that are used. The Cook/I protocol, which we're using on our most modern Zeiss lenses, and of course, Harry's LDS system, and now LDS2. Now, since Zeiss is a partner with ARRI for many years, we still make prime lenses in partnership with them. ARRI Zeiss Master Primes, ARRI Zeiss Master Anamorphic, and ARRI Zeiss Ultra Primes. We have been using the LDS data communication in those lens lines. So there is lens data in Master Primes, in Master Anamorphic, and the LDS version of the Ultra Prime. So this already exists for many years. And what we have done is take that a little step further, because some of the data that you were getting in LDS lenses or the traditional Cook/I lenses included, what the lens is, what manufacturer it is, the focal length, the iris position momentarily, like at that moment in time, and then the focus position momentarily at moment in time. What we've done is gone a little bit beyond, and Cook is doing this too, so we're not the only ones doing this in the field. But Zeiss has created something called extended data, XD, which also gives you lens shading and distortion characteristics. Like everyone's like, well, what's shading and distortion? Shading is quite simply like your vignetting characteristics. You know that from the center point to the edge of a frame, you're going to have a different exposure, especially when you open up your lens all the way. Whenever you open up your T-stop all the way, you have a bigger difference from exposure from the center of the frame to the edge. And nowadays, with the larger sensors that are seeing through more glass, with our full frame and larger sensors, you're going to see more of a difference, and it's going to become more stark and obvious. And then also you have your distortion characteristics, especially on the wider angle lenses. A lot of these straight lines are going to bend a little bit at the edges of the frames. The thing is, when you're mixing, data that you create or imagery you create in a computer with real life, you need to make sure that stuff matches. So the shading and distortion characteristics that the lens is giving you, that when it films real objects like a real person or a scene, we want the background and foreground objects that are computer generated to match that. And this is across the board in visual effects, in volumetric filming, and also specifically in virtual production, what we're talking about today. It's necessary. So normally, in an Ncam system, and Nic could speak to this more clearly, you really got to profile a lens, and the profiling the lens takes time, a half hour, 45 minutes. And then if your lens drops and breaks during the production and you switch it out with another one from a rental house, you got to stop production again to do it all over. So that one step right there is cut out for every single lens. So if I got a 10 set of CP3 lenses or a higher end lens like a Supreme or Supreme Radiance, we have the exact same metadata technology on the back pins and then also on the external connector. So you always are getting that data, doesn't matter what level you're working with. And then for all your lenses, your 10 set of lenses, your 14 set of lenses, or your 3 set of zooms, because we also license the technology to Fujinon, so the Fuji Premistas also sport the Zeiss XD technology. Now, what ends up happening is that in real time, not only do you need that shading distortion characteristics, but you really want the focus and iris data, and you want the calculated depth of field information as well. So just think about a TV show that you've seen like Mandalorian or any of these other shows or movies where they use virtual production techniques, where you're mixing, real life with animation or with computer generated imagery. You want to be able to tell, like, because your screen sometimes is only 10 feet away or 20 feet away, but you're trying to emulate like an object in the distance, like a pyramid that's 1,000 feet away or further. And the way you emulate that is you got to be able to blur that screen just the right amount so that it looks like the depth of field characteristics of the lens you're using. And so if you could communicate the information from the lens in real time, the focus and iris position, and the camera can calculate your depth of field information, this is the next step that everyone's working on. So Nic can tell you better, and Andy can tell you better from the Epic side, and Nic can tell you better from the Ncam side. But everyone's working on this and basically getting all the information as much as we can straight from the system, from the optical lens element, into the computer system, translating from the camera all the way to real live on the computer system. And the more information that we can give in real time, the better, the more accurate the imagery that the Ncam system plus the Epic engine, Unreal Engine can actually emulate more realistically and make it much easier for a cinematographer to really get that image that they're looking for. The blur to be correct, the look to be correct, the sharpness to be correct, and really give them a natural feel. Because all these little steps, I mean, it might seem like, well, how much shading is there? How much fall off is there? How much distortion is there? Or does it really matter, like, if you can get the depth of field exact? Well, all these little things actually help you as a viewer feel like this is a real shot. All these little tricks, because VFX does it all the time. The way that they do any VFX shot is they flatten everything out. They take out all the shading, all the distortion, they do their compositing, and then they reapply the characteristics of the lens in real time back again. And this is a normal practice. In the past, it required taking lots of charts and testing the lenses that they used in the camera systems to kind of give them an idea of what the lens is doing. But we're able to give you much, much higher quality, accurate data frame by frame with the XD technology because we're communicating the exact shading and distortion characteristics based on mathematical calculations of the lens design, which are super, super accurate. So we can give you better than, in VFX speak, better than a 10 by 10 or 12 by 12 grid. We can give you sub-pixel level accuracy very, very easily. And it's in real time, and you can use it right away. So even on this system here, if I change the focus on my camera, you can't see it quite clearly, but these green numbers are changing in real time, showing me how the shading distortion characteristics are slightly modifying to keep up with the focus and iris change. So this information is very important. It goes in the pipeline, and right now we're working on how to make that pipeline more efficient. So it takes that information and makes it useful for the Unreal Engine so that everything just happens right away. And basically then allows the cinematographer to make creative decisions instead of technical decisions. Because yes, on day one or day two, if they came off of another shoot that was shot on, without any virtual production, without any green screen or backgrounds, they can really start to tell like, okay, well, this depth of field should be like this, and this actually doesn't look correct. But you start to lose that kind of, consistency after day two or day three of the shoot because you're starting to see stuff that's very, very sharp and focused all the time. It becomes harder to realize what it would look like in a real life situation. And that's what we're trying to do is give them the tools where we can make it look as realistic as possible, and then they could tweak it. And that's what we're interested in. So we're working on it, and hopefully we'll have more robust tools soon, but we already have a working system that already works quite well with the Ncam system and other virtual production systems. And of course, the XD technology is already being used for multiple visual effects, TV shows, movies around the world, and you can see more information on our website about that.
So Nic, it's actually a perfect transition. Your world is real-time camera tracking. So when we say real-time camera tracking, there's all the optical elements that are actually being captured through the lens is really the key aspect of reproducing, a hyperreal or a matched environment to what the camera actually sees. So from your point of view, tell us how important it is to integrate lens data, lens metadata, anything that relates to the depth of field, the focus, the distance, the sort of the spatial environment, how is it being seen, the distance between objects, how important it is for the streamlining of your products to make sure that you get that data in real time.
It is absolutely integral. The lens data, metadata is integral for a number of reasons, and obviously Ncam's for sure we can do real time capture, real time camera tracking, real time graphics, and obviously plugging into Unreal Engine. But also, I think not everything necessarily happens in real time. And people may want to tweak in post production. And I think that that's a really important element as well to understand that the today and also the tomorrow. And so it's really important to be able to have the quality levels in real time, but also in post. So today the VFX guys will obviously calibrate all the lenses, and we might have to calibrate 60 lenses for a shoot over a couple of units, and that's a lot of time. And one of the issues is it's not just time, but it's also accuracy. So added to which you might have a handful of vendors, VFX vendors and post-production vendors on a single production, whether it's TV or film. And so every time the vendors have to do their own, typically their own lens mapping or profiling, however you want to call it. So if you can make that far more efficient, that process, there's huge benefits. But if you look at the way that Ncam's gone about the intrinsic and extrinsic parameters of the camera, so that is the camera tracking side and also the lens side combined with the chip, we don't separate it, and we never have done. So we've always had a way to calibrate a lens, whatever lens that is, whether it's spherical, anamorphic, zooms, it doesn't really matter to us, and we have to do that whether it's broadcast, film, live events. Again, it doesn't necessarily matter, and we have to be able to calibrate everything. But if we can take, if you can imagine, you have camera tracking, which is 6 degrees of freedom, right? So that's your position and your orientation. So X, Y, Z position rotations. That is one thing. But if your lens characteristics, so your focus, iris, and zoom, and your lens mapping or profiling isn't bang on, the CG and the real live video will slip, and it won't match up. And actually, that's fundamental to a really good real-time CG or post CG. It has to match up. Everything must match up, and it's fundamental, absolutely fundamental. If you got visual effects, it's camera tracking, right, and it's match moving, and that is lens calibration. So added to which, what's great about sort of smart lenses, and especially the XD system that Zeiss have developed, is that it's the level of quality that we can get straight out the box, where we don't have to worry about calibration. You can literally put the lens straight on, we plug it in, and away we go. There's nothing else to do. So if you then record all of that data, as we are with our systems, and we're syncing that with timecode on a per frame basis, we're then able to utilize that later on. And that later on may be maybe post viz, so might be hours after we've shot a plate. It might be editorial, where we're bringing in temp backgrounds for VFX, and it might be post-production where it's a few months away. That can all be, the quality can all be dialed up, or we can be, and the VFX guys can be changing things. It's just the flexibility that it offers, so you don't have to then fail because of human error, because we've haven't taken down the right lens, we don't know what the focal distance is, we don't know what the depth of field should be, and it takes out all that guesswork, and effectively that should be come into every package, whatever that is, whether it's Unreal, whether it's Maya, whether it's Nuke, or however this is working for everybody, right? You could still have that package of metadata all locking up. And so that just takes away huge pain, to be honest, and guesswork, because bottom line, match moving, post-production match moving, it's still it's still a manual process, and I think ultimately, this can become a lot more automated, and I think efficiency is what it's all about, right? Especially the amount of content we need to be generating today, and the likes of clearly the likes of streaming services.
So that your integration with Unreal, is pretty amazing, and I think that sort of really what sort of bridges the gap, and removes the boundaries of the disbelief, the suspending disbelief in computer graphics, visual effects, and integration with live is really what's key, to the success of these kind of content. So, and it all originates with image acquisition. And Andy, you and I met, I think, less than a year ago. I think you were here for a presentation that we hosted Nic for, and you and I started talking about the integration of lenses and optical data into your work. Tell me a little bit about what the level of interest that Unreal has into making sure that it's as seamless as possible, that the suspension of disbelief is just, it's undiscernible. You cannot tell what's live, and what's computer generated. So I think, you and I have talked about, how to get access to certain lenses to sort of broaden the spectrum of how to make the tool set better. So tell us a little bit about, what interests you and the motivation behind that aspect of the production with Unreal.
As you mentioned, we're very passionate at Epic Games about the filmmaking process. We've went about kind of hiring a lot of people from various industries that both come from the filmmaking world, come from broadcast and live events, and we understand the processes that filmmakers are looking to go through to be able to get the best image quality. So in our engine, there's been a lot of focus on quality and a lot of focus on the things that we've been describing as far as matching depth of field, matching vignetting properties, matching down to those levels of characteristics that you would get out of a cinema lens inside the actual engine. And for us, our goal is ultimately to be able to see your creation live and to be able to have the filmmaker make their decisions live there on set, rather than kind of postponing those changes, let's say, that you'd make way down the road. And so we do believe that the lens data is integral in being able to match seamlessly the CG composite with the live action video feed. As Nic was mentioning, we work with partners such as him to be able to, and their company, to be able to facilitate some of these. So we want to be able to bring in the lens data and all the lens deformation, the characteristics, even the chromatic aberration that goes along with it, to match down to pixel perfect, so that there's a seamless composite live there on set. And I think there's more and more of a interest in the industry to be able to see these visuals live on set while they're doing it. And I think some of that was mentioned before, but the Mandalorian technology that we had built kind of helped push things in that direction, to be able to alleviate some of the need for the green screen and to be able to get to final pixels live in camera is some of the goal. And with that, you need, as Nic mentioned, very accurate camera tracking that's sub-millimeter accurate camera tracking. And without that, it's fundamental. But the lens, what I love about the XD and what Zeiss is doing is that it's calibrated at the factory level. So for me as a, on set, I can trust that that's been calibrated to a high degree of fidelity. And as Nic mentioned, you might go through 8, 9, 10 different lenses in a given day. And just the process of making sure that those lenses are mapped and profiled, and that those profiles are loaded correctly, and all that kind of goes along with it, can lead to a lot of human error that's included in that process. And so I feel like the XD data that's provided is perfect move for the industry to start headed more and more towards the smart lenses. And then paired with the Unreal visuals of being able to see that action live on set and have those match, I think filmmakers are, just their appetite is give me more of this.
So a question for the group really is, do you think that the global lockdown that we've all experienced with the COVID era, do you think that maybe one of the silver linings, if there are any, is the fact that technology is going to be developed faster. It's going to be accelerated, to get better results in a shorter amount of time. Do you see that as a new advent in production and post for content creation? Is that LED walls and virtual setups are going to become more prominent than traditional production? So what's the general consensus or the vision that each one of you has about where our industry is going in that regard?
I could start off if that's okay. I would say the big thing is that we're going to see a change from green screen altogether, because that has so many drawbacks, especially like light spills, setups, cost, everything, to stuff like virtual production and Z-depth map. Like we're seeing this already. So this is a change that's inevitable. There'll be one day when green screens are dead completely and no one's going to use them, and they're just going to use other simpler technology that is really more camera based and it's easier to deal with. And already we're going that way. I mean, Ncam has a system that can work very small and it's easy to put on any camera system. So we're already getting there. And every camera company is developing Z-depth type of mapping. It's industry secret. Everyone's after this. So we know this. Lytro camera, the best thing that the Lytro professional camera did is Z-depth mapping. You can cut out a background instantaneously because I had multiple lenses looking at an object. So this is something that's happening, and we want to be in the forefront of that, because at the end of the day, it's not like we make VFX better by doing this, but we're cutting out labor that costs time and money that could lead to a better product, because the taste in 2020, the average viewer has much higher taste requirement for visual effects than someone maybe even 3-4 decades ago. Like, we really want realism, and we use it so often. What most people don't understand, that visual effects are a very common thing for the most basic of television shows. There's so many set extensions, there's so much painting, there's so much wire work, little things done that you just don't notice. And it's good that you don't notice, but that takes such time and effort and extra cost that if we can significantly bite into that cost, it just gives the production more time and money to put into the creative, so they could spend more time working on the shot or making the virtual production stage and production design better and more conducive to telling a story than worrying about the technical stuff. That's what we're trying to do. We're not trying to upend the system and completely change it. We're just trying to make it easier to spend more money on the creative and less on the technical stuff.
So Nic, streamlining the process, is that something that you guys think about?
Yeah, every day and most of the night. So I think look, we as a company, we came to this through a filmmaker's view, and that was simply a frustration that when I used to go on set and visual effects and supervise and previous supervise, we just couldn't visualize anything in real time. We just had this mass green screen and blue screen, and when you look through the lens and you got a couple of actors, you just can't align a vision with your filmmakers and stakeholders, and ultimately there was just a technology gap, right? So some of us have been doing virtual production for the last 20 years. It's just there were certain things that had to happen in order to make this a reality, and one of those was getting an engine that was good enough and will then push the boundaries massively, which frankly Epic are leading the way, and with Unreal it's just phenomenal. So that's changed kind of everything, and enabled us all to now create real-time high fidelity imagery that ultimately what we want to do, we don't want the filmmaker or the viewer to be able to distinguish between what's real and what's not. And like we used to shoot films, we want to shoot it through the lens and in real time, right? That's the vision, and you shouldn't care if it's real or not. And it's up to us to really develop that type of technology and work with all our partners, which is what we're doing to make that reality. And that's just the way it's going to be. And it's not for technology's sake. It's to make better pictures. Ultimately, it's all about the quality, and it's about pushing the boundaries of that. And it's the time, right? The time it takes. So the more efficiencies we can bring, the better the tools, the better the quality ultimately.
So, Andy, that brings me to you a little bit. The same sort of extension of these questions is the photorealism nature of what Unreal can actually bring to the equation. Was it something that was a long-term development goal of Unreal, or was it sort of a way the direction of the industry was going, and you said, oh, you know what, we have the perfect tools to be a big player there?
In a lot of ways, Epic is a company that just strives for the highest quality possible and was already doing that within the games industry. And I think when we launched Unreal Engine 4, there was a big shift for, some architects started using it early on and started doing visualizations that were rivaling the stuff we were seeing out of V-Ray and some of the offline renders. And so each release, we're on the 26th release of the Unreal Engine 4, and we've shown off what Unreal Engine 5 is, has just upped the bar, up the bar, up the bar. And then with starting around 4.20, we started to really focus more and more on the actual virtual production tools that filmmakers need in Engine. And that has, as Nic said, empowered a lot of the filmmakers to finally, they've had these visions and grandiose visions of being able to do this stuff, but there's never been the technology available for them to actually do this fully live. And so combining a technology like Ncam and combining it with a best-in-class renderer like the Unreal Engine, you can actually bring that stuff on set. And so the trends I'm seeing in the industry is more on front-loading some of the production so that these assets are ready and available to, when we go to shoot, are built to a high level of fidelity so that we can shoot them in an accurate way. When you look at the stuff like on The Mandalorian, those sets had to be built and ready to go. So there's a shift in some ways to do more on set. I wouldn't say get away from post-production altogether, but work smarter, not harder, in the sense, like we were saying, there's a lot of extra labor that's just kind of monotonous work that's in visual effects, whether it's on the tracking side or green screen cleanup side or things like that, that I think the real-time technology actually brings a huge advantage to. And that was some of the discussions early on with Industrial Light and Magic, was how far could we push this? Could we actually get in-camera final pixel shots? And for us, when we first started, there was a big question mark there until, we actually kind of were like, okay, let's try to do this. Let's set out. And I think that's caught the industry's attention, in terms of wanting to be able to do these techniques on set. But it does require kind of the three parties that we have here represented to all work together. And I'm glad to see the industry really moving in the right direction. And that's kind of what we discussed, when we first met, was how do we get these things calibrated down at the factory level so that we can easily swap lenses on the day of the shoot, without much trouble? And how do we record that data accurately in Unreal so it can flow into post-production easily? And there's definitely a big focus of time and energy internally at Epic to kind of fulfill that vision and bring those tools about.
And there's another level to it too, Michel, which I mentioned earlier about the realism. Like all of our companies, we're trying to make the image as realistic as possible, right? In whatever story sense that is. Doesn't matter if it's surrealistic or hyper-realism in terms of the storyline. We're trying to make it fit within that storyline, and that requires massaging. That requires massaging the image to get to that point. And people can tell intrinsically when things look fake. Things look like they're shot on a green screen or when VFX don't look right, they might not know how to explain it and say, well, your image field is flat and everything looks really flat, but the professional will be able to see it. And if we're able to recognize these things and kind of massage the data to be the driving force of getting to that realism instead of rote labor, instead of making someone go frame by frame and rotoscope and change stuff, where we can skip that process and really give them the realism that they want, is exactly feeding into this whole idea that when I go on set, I set up the camera system and I have the backgrounds and everything works. And then in post production, what am I doing? Fixing little things, working on color correction, but not redoing the compositing of the whole image again. This is what is trying to be avoided. And by adding these little layers on, you might think this is a small thing, like, oh, it's just lens data. But it makes such a big difference of trying to get that realistic image that the way that the cinematographer wants it. And it goes a long way to really help the filmmakers. And honestly, that's why we're doing this. At the end of the day, you can hear Nic in his voice. He's a VFX super that left the industry to develop a tool, that helps his industry. And Zeiss has a lot of experience from the 1910s onwards in film and feature film. If we don't listen to our filmmakers, then we're really not doing the right job. And I think that's what we're trying to do, all of us, is listen to the filmmakers, pay attention, give the solution that they want, and make it as easy as possible. Literally put a box on your camera and you're done. Great. That's awesome. And in the future, if it can become even more plug and play, where camera systems are integrating like the Ncam technology, even better, even better.
Yeah, I mean, the one thing that has been striking to me, I have a long career in visual effects. I don't want to date myself, but the late 80s is when I started in this business, and I've seen the industry evolve in ways that really I wasn't expecting. And my nights of match moving into a computer system, sort of almost disappeared. And my years of making sure that I'd be the one VFX souping on site to make sure that I have my tracking markers wherever I need them. Now I can just go, hey, Nic, give me an MK2 system, and then I'm done. So I think I think it's all the striving towards the quality of the output in the end that really is the motivation. I think that's critical. That's one of the incredible aspects of our industry is the innovation level that we see, and Zeiss coming up and say, okay, extended data is a good idea. We're going to pursue it because it's going to become a standard, and other people are going to adopt it. And here we are. All the manufacturers are adopting the technology. And the same thing for you and for you, Nic. I think the idea of real-time camera tracking a few years back was like, wow, this is absolutely extraordinary. It's like no one does that. Now it's like, okay, I'm going to do motion tracking on the set. It's going to be live and it's going to be real time. It's going to be super accurate. I think there's a level of comfort that I think really brings the quality of the creative process higher. And then I'm going to go, making the rounds. I'm going to go to Andy. I'm on these virtual production forums, with all these guys out of their little garage, and they use your engine, and they do stuff that's absolutely extraordinary. You say, okay, where are the boundaries between the computer graphics imagery and the photorealism? So I think that's a testament, to where our industry is going, and I think it's terrific. It's a strive towards quality. So we getting near the end of our time here in this session. But before we do that, I would love to see or to hear from each one of you if there were 3 goals that you have in the R&D, the development of the new tool set that you want to see for the industry to be engaged in. What would they be? So I'll start with you, Snehal.
Well, one of the most important things that we talked about actually even before we started recording with Andy and Nic is the idea that the lens focus and iris data move in real time, and the depth of field calculation, because each nowadays digital camera system has a slightly different way of calculating depth of field based on pixel pitch and entrance pupil position in the lens and stuff like that. So it would be nice to get that data in real time as well, because that's becoming more critical. We're seeing that's the one piece that's missing like first season of Mandalorian, for example, or other big shows, is that having that critical information allows the cinematographer to set up the camera and the lens, and then automatically the background blurs itself or sharpens itself to match the depth of field that you're creating in the foreground. And this is really important for the screens because those screens can be different distances away, right? Like you can have a big screen that's far away, like 30, 50 feet away, 100 feet away, or you can have a screen that, you're doing just a window, and so it's only 5 feet away from the camera or 15 feet away. And then it becomes different because that screen has to emulate something that might be a really long distance away, like a background outside of a window of a moving train, etc., where the screen is really close, but it's emulating something that's far away. If that's the case, then that screen has to be blurred just the right amount to match the kind of look that the lens is supposed to give. And that difference right now, we're getting closer to being able to do. And that's going to be important for the cameras and the Ncam system and other virtual production systems to communicate fast with Unreal and then make that information available and actively change the backgrounds and the foreground objects automatically. This is really the next big thing that we're looking for. Aside from that, we're just looking for more compatibility with camera systems and more compatibility with your post-production system. So having to get that data inside, a box or Unreal or whatever package it is, but then exactly like what everyone said, being able to go in post and also still enhance it, because maybe you still want to add other things, once the image is created. You want to add some more planes flying by or, extra effects. You should be able to do that easily. And if you all are working in the same system, and everyone has the same type of data that's moving along, it's going to be good. The great thing about the Zeiss XD system, it is the same data. So the data that a virtual production company setup would use, or a visual effects team would use, or someone using it for volumetric filming with a ring of camera surrounding an object, they're all using the same type of system with the same type of data. So at least that part's very easy to understand. And now we just want all the other steps to be the same way. So those are the three things I would say are kind of next. That Zeiss is seeing as important for the industry.
Nic, what's your take on that?
Yeah, I think so. So what's exciting is that we have the ability to do all of that pretty much today. So because we can understand, it's really important to understand where the camera is in space on a very accurate level. Whether whether it's indoors or outdoors, right? You need it. So, and that's relative to objects in the scene. And those objects may be an LED screen, it may be a green screen, but we know and can measure that in real time. So we're able, because we have intrinsic, extrinsic parameters. So we know the focal length, we know fizz. So we've got focus iris zoom, we know distortions, we know breathing, we know exactly where the nodal points are. Optical centers, we know where the chip is, we know what size it is, we know how it reacts to light because we've got the model, and eventually we can just replicate that whole lot, and we can drive the LED, whether it's an LED screen or not, we can tell it where the image should be, and fake it. So you're going to get your depth, you get your all your distortions, and in real time, and there shouldn't be any delay whatsoever. So we take data straight from we don't go through the camera, we take it straight from the lens that plugs in straight into our new system, the new Mark II server or connection box, and then we use that data in real time. So we're in charge of that data, and then we sync it with everything else. So, and then we just plug it through and send it to Unreal Engine. So within the current framework. So that this is all super exciting and right. This isn't stuff that's in the far distance. This is right here and right now, and that's what's kind of cool. But also the interesting part is where it goes next. And I think we do need some standards within the industry. So we really do need to all work together and agree on some standards for sure. Make sure that we're able to share data real time and not real time, because there's nothing to stop people cranking up quality or changing things and iterative changes within Unreal Engine, right? It doesn't have to be real time finished. There's nothing that stops you from potentially from doing it 2 seconds later, right? And I think that we shouldn't forget that. and then ultimately, really, for me, this is just the beginning. So this is simply the beginning of a very large change in content creation. And that is super exciting. So LED screens, yeah, you know, they're good in many respects. They are, you know, not the be all and end all, not a super, you know, not a silver bullet. And ultimately, I think what we need is to understand. We have to understand depth on a per pixel, sub pixel basis, right? And you shouldn't, you know, whether you're indoors, whether you're outdoors, that's what we need. We need it in real time. We need it in non-real time, and we need a bunch of other things to simulate and make things look and feel as real as possible. And effectively, what we're doing is we're going to try and recreate the world in a virtual manner, but in real time, right? So 3D video on per pixel level. So yeah, I think it's going to take a lot of different companies and a lot of passion and a lot of expertise and a bit of time to do. But I think what I'm seeing and what's really exciting is that companies are working together, and the three of us are working together quite closely to make some of this a reality. Obviously, it's going to take lots of other, you know, people as well and their expertise and skill set, and we're just part of that puzzle, and we're delighted to be a part of that puzzle.
So Andy, we'll finish with you. Unreal being really sort of the preeminent real-time render engine, you know, in the industry. Where would you like to see, you know, the work that you guys are doing? Where would you like to see that go? You know, it's more realism, more quality, better understanding of the spatial relation from a physical camera to a virtual camera. What are the tools that you guys are developing that would sort of go in the same direction of what Snehal and Nic have mentioned?
Yeah, I think both guys had great answers. I think those are things that the industry absolutely need. You know, for me, there's a couple things that are still big on the list. As Nic mentioned, like getting accurate depth per pixel on the image, so that we can take that into post, I guess, or massage things after the fact. I've seen a lot of research lately on like AI segmentation and things like that I think will also help assist that, speed it up, it'll go even faster. But I'm imagining, if you think of the typical VFX tasks, there's roto, there's tracking, there's acquisition of the HDRIs and the captures. I think, you know, we'll see all of that happening in real time on film sets within the next few years. You know, I think that's something that you know, we'll be able to capture, not only shoot, let's say, on these LED screens, but also capture the HDRIs so that we can take those back. And as you say, we're going to augment and put some chips in post and those things. But I think we're going to record the data in different ways, as Nic was kind of alluding to, of, you know, walking away from set with a lot more data so that we're not starting off completely from scratch, but, you know, we've done 70% of the work on set, and now we're kind of making the pixels as beautiful as possible after the shoot is done. I think we're going to see a lot more work in that area being done. I know for us, Unreal's starting to become the hub of the production, so there's a lot more around data management and the things that are handoffs to vendors. So there's the universal scene description and other things that we're investing heavily in. This is more on my broadcast side of things, but I think SMPTE 2110 and IP video may potentially change the industry, you know, at large once that's adopted at a higher level. It may also allow for more distributed computing, so being able to scale up these sets to many machines, or not even have the machines on-prem, but, you know, stored more in the cloud and stream back the pixels needed. So I think those are all things that are, you know, on our radar, that are things that we're, you know, currently working on. But yeah, I'm really glad that we could kind of get on and talk as companies. But I do agree that we kind of need to be aligned and focused on some standards that everyone can hone in on and share. And so I'm all for that as a company.
Yeah, I think that's the role of SMPTE. So maybe we can start a standard group at SMPTE around virtual production and integration of camera and lens metadata. I think that would be terrific. You know, just to the fact that you mentioned that 2110, is an important part of our future. It's actually for larger companies, networks and people who do live shows and deployments where the transition from sending everything separately is now merged into one level of transport, and that's 2110. I think is making things a lot easier. And it's also important for us to realize that, okay, we can combine image, sound, lens metadata, camera metadata, scene description, computer graphics object created, distance to the wall, all kinds of things, just like you said. You came in with a single drive of data and you come out with 5, right? And I think that's really the exponential area of where you get the beauty of doing something real, and sort of meaningful on set. Because we love green screen, but in a lot of ways, it's not meaningful when you capture it, right? It's very abstract. So
I mean, I see it as though we're moving toward a time where you typically deliver plates, and that was kind of all the handoff was, and then it's plates and camera. Now potentially it's plates, camera, a load of metadata that goes along with every single frame that happened during that production, so that you can easily reproduce it, and it's in some kind of layered format already pre-set up for the comps and different things. Like that's where I see the industry headed toward. I mean, we're not there today, but I think that's where the vector we're on.
Yeah, I agree, Andy, and I think you not headed. Yeah, maybe not today, but tomorrow. So I mean, there's so much going on right now. There's just so many projects going on that I'd love to talk about, but but I can assure everybody that it is changing quickly, and it's great, the fact that there's certainly people who are embracing it, and I think the right people all over the industry, and that's taken a little bit of time, and I think that's one of the silver linings of COVID for sure. It really has accelerated. I mean, we do hundreds of demos during the last whatever it is, and every time everybody's just saying, it's just giving them the time to sit back and think about the future a little bit more, and that's enabled them to do a bit more research and figure it out, and that's great. That's got to be a good thing.
All right, so the future is bright as an LED panel, right? So
and we're being driven by demand. Just think about it. You mentioned the COVID thing, but there are so many people thinking about, okay, how can I now make use of virtual production? Just the fact that if you have actors and talent in LA and above the line staff in LA, getting them out to a location now we know is risky. So if we can keep everyone in a contained environment and work in a studio, every major production company that has anything to do with virtual production is now looking at opportunities like this. So it's a great time to talk about this because there's a lot of attention on it, how to do that. It makes sense. You could send your principal camera team and your DP out, grab your background plates, and then the next week you could be shooting on a stage for a whole week with those background plates. And that's a big deal. It's a really, really big deal. So I think all of that added together is the driving force. And we have to make a use of this opportunity and give the tools to the artists that they need.
Yeah, I mean, that's what's wonderful about our industry, right? Is if tools exist, they'll be used, in ways that we haven't thought before, and that's how, our industry is extremely innovative in that regard. So I want to thank everyone. You guys have been great. This is a terrific conversation that demands more, and maybe we'll do it again, not next year at SIGGRAPH, but maybe sooner, and maybe in person, right?
Yeah.
So, in the meantime, I want to thank all of you. Snehal, thank you very much, my friend. Nic, from England over there, thank you for making the time for us again. And Andy, we shall continue working together on lens metadata integration into Unreal Engine. So all that being said, you guys stay safe, and hopefully we can get together in person very soon. Thank you very much. Okay.